So now we look at solving absolute value equations. Just a reminder to graph them. Anytime we had the y equals the absolute value of x, we had this V shaped graph as we go through it. And so when we go to solving them, if you think about, if I have a graph, okay, and I put a V on there, an absolute value. So I'll just go like this. So if I were to solve an equation, like instead of y equals x, we had the absolute value of x equals 3, something like that. Well, I'd have this v, and then I'd have what it equals. And so if I look and say, okay, it equals 3. Okay, so it has this line coming across like this. We can see the graph hits twice, so I'd have 2 solutions to it. Or if I drew a line, and I move my graph around, I could say, hey, it hits once right there at the bottom. Or if I drew a line below it, it could be no solution. So understand, that's kind of how we're going through and solving these equations. So our rules to solving is isolate the absolute value. Then we're going to go ahead and write 2 equations. And then you solve each equation. So we'll go through this. So what I do anytime I want to isolate the absolute value, okay, so I come through here, I circle the absolute value. On that side is that 2, so I need to get rid of that 2. So I get rid of it. So then I have the absolute value of 3x is equal to 6. And then I write my 2 equations. 3x is equal to 6, or 3x equals negative 6. So we just switch the sign. Then we solve for those ones. So x is equal to 2, or x is equal to negative 2. Come here, I want to solve. I want to isolate this absolute value. So I need to get rid of that 2. So I add 2. I still have that 3 on the outside of this absolute value. So then I have to get rid of that 3. So then I have 4x minus 5 is equal to 7. That has an absolute value. So now that I got my absolute value isolated, now I'm going to write my 2 equations. So 4x minus 5 equals 7. Or, so I could have a distance of 7, or I could go to the left 7. So it's always going to be, once I isolate my absolute value, what's away from the absolute value will be positive and negative. So then I solve this equation. So 4x is equal to 12. And then divide by 4, and x is equal to 3. Or I add the 5. 4x is equal to negative 2. I divide by 4, and x equals negative 1/2. So both of those would be a solution. If I come to number 3, we want to isolate the absolute value. So to get rid of that 1/2, I could divide by 1/2. So I could say, hey, divide by 1/2. Or I can multiply it by 2. So that's what I'm going to do, is I'm going to multiply by 2. I have x plus 2 is equal to 20. And then I write my equation. X plus 2 is equal to 20. There's one equation. Or x plus 2 is equal to negative 20. So then I go ahead and subtract. X is equal to 18. Subtract 2. Or x is equal to negative 22. So then I come through here, all right, and I would need to get rid of the 5. So I have equals negative 4, and I have negative 2 times 3x minus 6. So then I divide by negative 2, and that is a negative 4. So then I have the absolute value of 3x minus 6 is equal to positive 2. And so then I write my 2 equations from there. 3x minus 6 is equal to 2, or 3x minus 6 is equal to negative 2. And then I solve from there. So 3x is equal to 8. Now when you get to this, you can just leave it as x is equal to 8/3. Okay, so that's fine. And when you come to this, 3x is equal to 4. So you can leave this one, divide by 3. X is equal to 4/3. You could leave that as a negative as well. Now, when you come to number 6 or number 5, so again, I'm going to isolate my absolute value. What happens is your absolute value of x plus 1, negative 5 in front, is equal to 10. Then I divide by negative 5, and I get the absolute value of x plus 1 equals negative 2. Can your absolute value equal negative 2? Well, no, because absolute value is a distance. So can you have a distance of negative 2? No. So this would be like when we graphed and our line was below it, like that one right there. So we'd say at this case, no solution. And you are done from there. You're also going to have a situation like this. X plus 3, you add 3. So we're getting this by itself. So you have 3/5. Absolute value of 2x minus 4 equals 0. So they cancel each other off. So then I times it by the reciprocal 5/3, times it by 5/3. Well, then I get 2x minus 4 is equal to 0 times any number would be 0. So I get 0. Now it's okay if it's 0. The only thing is it's just going to be one equation. 2x minus 4 is equal to 0. Because if I said 2x minus 4 equals negative 0, it doesn't change it. And so I solve for that. So when you go through and you solve for these equations, there may be a case where just you get one x value. It may be no solution. If your absolute value, once you get your absolute value by itself, it equals a negative, then it's no solution. Or you could have two solutions as you work through it. So just remember, isolate the absolute